In this video, we're going to learn about the behavior of an inductor in a DC circuit. Okay, so here I have RL circuit. R is a resistance, L is inductance with a battery source. Battery is a DC source here. So the two important points I want you to remember all the time. The first one is inductor stores energy in the form of magnetic field. The value of energy stored is half Li square, where L is the inductance value, I is the current. Okay, L is the inductor, which is in Henry. And the second important point is inductor always oppose rate of change of current. Okay, it always opposes the rate of change of current. Now here I'm going to make a table. We are assuming at t equal to 0 the switch is going to be closed. So at t equal to 0 minus, that means I'm about to close the switch. My hand is on the switch, but I haven't closed the switch yet. What is the voltage drop across resistor? It must be 0. Voltage drop across inductor, 0. Current passing through it is 0. Because switch hasn't been closed yet. For current flow, there must be always closed switch. Now, at t equal to 0, I just closed the switch. At t equal to 0, that's what the t indicates. By the way, the time frame I'm talking about here is in probably milliseconds, microseconds. Okay, very small time frame. So that time frame is called transient state. So basically I'm talking about transient state. Okay, so at t equal to 0, the voltage drop across the resistor is going to be 0 because it opposes, the inductor opposes the rate of change of current. So at 0 minus, inductors are 0 amperes. At 0, it won't let the current change 0 immediately. So still it's going to be 0 amperes. So V are equal to 0. So all the voltage will appear across the inductor. After a few milliseconds, 0 plus plus. Now probably it will let some voltage across this. I'm just giving hypothetical numbers, but how to get those numbers I will tell you the exact equation in a minute. So V are equal to 3 volt. So the remaining voltage 7 volts will appear across the inductor. So I equal to 0.3 ampere passing through it. 0 plus plus plus. I'm still talking about in milliseconds or microseconds depending upon the RL value. 0 plus plus, it's going to be say a 6 volt across the inductor or across the resistor, and here it is 4 volt. It's going to be 0.6 amperes. So after 1 second, 1 second is a very long time. Okay, after 1 second all the voltage will appear across this, the remaining 0 volts here, so 1 ampere passing through it. Okay, as I mentioned, this is called transient state. Transient state. Okay, so transient state is nothing but what is going on in the circuit just immediately after closing switch or immediately after opening the switch. That's what we are talking about, transient state. Okay, so in transient state, what is going on? In transient state, inductor will start storing energy. So in this state, inductor start storing energy, or inductor stores energy. I would say inductor stores energy. Okay, and transient state is only few milliseconds. Okay, milli is 10 to the power of minus 3 or microseconds depending upon the RL value, but the transient state is only less than a second. That's what I want you to know. Okay, so in transient state, after doing this, in transient state, inductor act like a open circuit. Okay, so it will start storing once it is fully energized. Once inductor is fully energized, in once it is fully energized, that means so few milliseconds. Okay, once inductor is fully energized, it acts like a short circuit, because we know that we saw that what is the voltage drop across inductor? 0 once it is fully energized, so it will act like a short circuit. So based on this, what I can tell you, in steady state, inductor act like a short circuit. Okay, so if you remember, capacitor acts like a open circuit in steady state, inductor act like a short circuit in steady state. Okay, so basically if I draw a graph, let me draw the graph here. So here is a RL circuit, so the current is going to increase exponentially. So say that's Imax, that's the current. So this in time in seconds. So similar to that, this value I of t equal to I naught, which is the final value, times 1 minus e to the power of minus t over tau. Tau is similar to the previous case, I mean in RC circuit, tau equal to when it reaches to 62.3% of the final value. Okay, and I can tell you I naught equal to VR over R in this case. Now if you look at the voltage drop across the inductor, is going to be go down, it's going to be something like this. That value VL equal to V naught times e to the power of minus t over tau. Tau is similar to the RC circuit, tau equal to time constant that value is L over R. For RL circuit, it's L over R. So time reaches to 62 point, time taken to reach the 62.3% of the final value when it is increasing. When it's decreasing, so the tau value here, let me use the blue, it's going to be the remaining, what is that value, 37.7%. So that's a time constant.